Okay, so first section we'll take a look at is section 1.1 in the book. Pretty straightforward, just goes over some basic stuff. Okay, I'm not going to write down all the different definitions here, but I'll just kind of quickly go through the different types of numbers we have, starting with the simplest numbers, which are counting numbers. Counting numbers don't include fractions or decimals. Okay? They don't include negatives. And when you count things, what number do you generally start with? 1. Okay, so counting numbers start at 1, and they go up from there. 1, 2, 3, 4, 5, 6. No negatives, fractions, or decimals. The problem with just limiting ourselves to counting numbers, somebody give me a counting number.
4.
4. Okay, if I did subtraction, let's say I do 4 minus 4. Okay, I run into a little problem, because counting numbers don't include the number 0. So unless we're going to, if we're just going to restrict ourselves to counting numbers, you can't do 4 minus 4. You'd have to say it's undefined. Unless you want to go to the next set of numbers, which now is called whole numbers. Only difference between whole numbers and counting numbers is whole numbers include 0. All right? So that lets us do a little bit more. Now you can subtract two numbers and get this thing called 0. That's a whole number. But there's still some problems we could run into. Not so much with addition or multiplication, but with subtraction and division. Can anybody think of a problem with subtraction where I could do a whole number minus a whole number, and the answer is not a whole number? Remember, whole numbers only go from 0 up. Still, no fractions, no negatives. Yeah, go ahead, Adrian.
3.
What is it?
2 minus 3.
Yeah, what kind of number is that?
-1.
Yeah. So with whole numbers, negatives don't exist. So if you try to do 2 minus 3 and you don't believe in negative numbers, you have to say undefined. You can't take away more than you have unless you're going to invent a new kind of number called negatives, and that's where integers come in. Okay, so now integers include all your positives, all your negatives, and 0, which is neither positive or negative. But even with integers, we could still have some problems with just basic arithmetic. You can add integers, you'll never have a problem. You can subtract them, you can multiply them. But can anybody think of something that could happen with division, where you take an integer, divide by an integer, and we get something that doesn't exist yet? We haven't talked about them. Yep?
Would it be a fraction or a decimal?
Yeah, we don't have fractions or decimals yet. So, for example, if you tried to take 3 divided by 2, you can't do that. Okay? If you don't believe in fractions and decimals, 3 divided by 2 is undefined. It's like trying to take 3 objects and divide them equally between 2 people. I can't. All right? It doesn't go in evenly. So that's where we get our next set of numbers, and that's the rationals. Okay? Rationals include all your positives, all your negatives, all your fractions, and all your decimals. So for everyday kind of life purposes, most people don't need to know much more than rational numbers. Okay? That's pretty much the limit. Especially like cooking, might use 2/3 of a cup of something, or, there's your fractions. But there's still numbers that aren't even fractions, and I'm going to get to those in a second.
So rationals can be like positive, negative.
Yep, your rationals, those are your positive, negative, include 0, can be fractions, or decimals. Fractions, decimals, same thing. Okay, your integers, those are only positives, negatives, and 0. Whole numbers are basically just positives and 0. And your counting numbers, basically those are just your positives. They don't include 0. So each number set that we kind of expand out, it gets more and more complex. Right, so irrational numbers are numbers you cannot write as fractions. Okay? Anybody think of a number you can't write as a fraction? Ian?
Pi.
Yep, pi. So you can't write pi as a fraction. Any square root that's not a perfect square, like square root of 2. That number can never be written as a fraction. It's impossible. Okay, square root of 5, square root of 7. Square root of 9, that's a little different. That's a perfect square. Okay? So irrationals include things like pi, square roots of numbers that are not perfect square. So I'll just call them non-perfect squares. And those are pretty much most of your irrationals. Now together you take all the rationals and irrationals, put them together, and we call that the real number system. Okay? And in Algebra 1, that's pretty much where you stop. Okay? Real numbers is everything you study. In Algebra 2, you extend it to a new kind of numbers we'll talk about later on, and those are called your imaginary numbers. Okay? But we're not going to talk about those yet. Okay, so any questions on the number set? Okay, those are the basic kinds of numbers we have. Okay, some symbols that we use to abbreviate different sets of numbers. Okay, in the book, if you see this symbol, it looks kind of like a Z, stands for integers. Q, they use that symbol to stand for rational numbers. And R stands for reals. Okay, that is how they draw them. I think R for real makes sense. Okay, even Q for rational kind of makes sense. If you think when you divide two things, that's a quotient. Rationals are fractions. When you divide a quotient. Z for integers, not really sure where that abbreviation comes from. Okay, there are 4 operations in math, and we've already talked a little about them today, that are what we call binary. Binary means you need 2 things to make it work. Addition, subtraction, multiplication, and division. Okay, I can't say to you to do 3 plus and tell me the answer. 3 plus what? Okay, to add, you need 2 things. Okay, same with those other operations I've listed. Can anybody think of an operation in math where you don't need 2 numbers? Yeah?
Doing something to a power.
Yeah, I could raising to a power. You don't need 2 numbers to do that. Yeah.
Square root.
Yep, a square root. I could just say take the square root of 10. You don't need 2 numbers to do a square root. That's not a binary operation. These are the 4 that are. Right, and then there's some different properties we'll take a look at. Okay, I'm not going to go through all of them, but a lot of them you've probably seen before. Okay, so all these properties I'm going to take a quick look at apply to real numbers. Okay, so I'm talking you can use positives, negatives, fractions, decimals, 0. Okay. All right, the idea of closure means if you do that operation with 2 certain kinds of numbers, the answer you get is the same kind of numbers. So what this is saying is if you add a real number to a real number, you'll get a real number. That's always true. If you add 2 real numbers, you get a real number. I showed you guys earlier something where closure wasn't true. I said if you subtract a counting number from a counting number, you might not get a counting number. Right? So closure does not work for subtraction if you use counting numbers. Closure does not work for division if all you believe in is integers. Because I can take an integer, I can divide by an integer, and I will not get an integer sometimes. Right? For example, 5 divided by 2. Integer divided by integer, answer is not an integer. That means it's not closed. You don't get the same kind of number that you started with. Okay, that's probably the trickiest property. Any question on closure? All right. How about if I did addition with counting numbers? If I add a counting number to a counting number, will I always get a counting number?
Yes.
Yes. So we could say addition is closed for counting numbers. You always get back what you started with. Commutative property, these are just basic ones, means you can add two numbers and switch the order. Doesn't change the answer. Associative, okay, that means you can change the grouping, or the order you do things in, and still get the same answer. So if you add three numbers, it doesn't matter if you add the last two and then add the first one onto it, or add the first two and then add the last one. Okay, identity. Identity is something you can do to a number that doesn't change it. Does anybody think with addition, because those are the properties we're looking at, what can you do with addition that wouldn't change the number? No matter how many times you add this number, it never changes. Yep.
Adding zero.
Yep, adding 0. So for addition, the identity property is this. For multiplication, it's not multiplying by 0. That would change it. What do you think it would be for multiplication? What do you multiply by that doesn't change it? Yeah, multiply by 1. So there's an identity property for addition. There's one for multiplication. Okay, inverse, that's what you can add to a number to make it 0. Well, just add its opposite. If you add two numbers that are opposites, you get 0. And the distributive property basically just means you take what's on the outside of the parentheses, you multiply it on the inside. And a lot of these properties also work for multiplication, but I'm not going to go through them all. For example, with commutative multiplication, you could say A times B is the same as B times A. 2 times 5, 5 times 2, same thing. Okay, so they have all these same properties in your book for multiplication. Right, so an equation. Very simply, an equation is anything that has an equal sign in it. So you have something on the left, you have something on the right, and you put an equal sign between them. This is 3 different types of equations right here. Okay, the first one is called a conditional equation. It's an equation that could be true if you pick the right value for x. 2 times something equals 12. Okay, the next one, 5 equals 2, that's an equation. It's a false equation. It's not true. It's an equation that no matter what you try, it's never going to be true. And the bottom equation, we call this an identity. It's an equation that is always true. 7 equals 7. Okay? Where you might get something like this, just make up a problem. Okay, if I asked you to solve that, you're basically going to get the same thing on the left and the same thing on the right. So you'd have a 2x on each side, you could subtract it, and it would cancel, and you'd get 6 equals 6. It's an equation that's always true. Pick any number you want for x, it always works. These are 3 types of equations. Any questions on those? Yes?
Which was the first type of equation called?
First equation, that's called a conditional equation. Conditional means that it could be true if you pick the right value. So conditional equation, this equation is a contradiction. It's always false. This equation is an identity, the bottom one. It's always true. Right, so example 1 is just going through using some of those properties that we had on the other page. Okay, when I do distributive property, what operation is that? Is that add, subtract, multiply, or divide? Yep, James?
Multiplication.
Yeah, you're just multiplying. So all they're really asking you to do in the first step, and I would normally do this in my head, they're asking you to multiply 2 times x and 2 times 3. Okay? That's strictly distributive property. Now, simplified means just do out what you can. 2 times x, can't really do much with that. But 2 times 3 is 6. Now, I don't quite have the same thing on the left and the right, but I'm allowed to switch the order when I add 2 things because of the commutative property. Okay, so the way you might see a problem like this on a test is maybe I would give you the steps on the right, and I would ask you the steps on the left. Okay, why can I switch the order? You'd have to say commutative property. Okay, or why can I multiply this 2 out? You'd tell me distributive property. Okay, so it's basically just solving an equation. You're just telling me the steps you're going through. That's all. And of course, that's true because it's an identity. Same thing on the left and on the right. Okay, so any questions on those? Going just through those steps? All right.
Did you go now?
Yeah. So the coordinate system, we're going to start out really simple, not even having an x and a y axis, just having a single number line. Okay, the point where we have 0, okay, we call that the origin. When we get to an x and a y axis, it's also called the origin, where the x and y axis cross. Okay, positive numbers go right, negative numbers left. And once we kind of have this concept of a number line, then we're giving order to numbers. Okay, numbers to the right are always bigger than numbers to the left. And these are the 4 symbols that we can use when we're comparing numbers. Anybody tell me what that first symbol is? Denver? Yep, less than. How about the second symbol? Yep, Adrian?
Less than or equal to.
Less than or equal to. Okay, that third symbol?
Greater
James?
than. Greater than.
Yep, greater than. And the last one is a greater than or equal to. Does anybody know what you call these 4 symbols? Begins with an I. They're not equality symbols. That's just the equal sign. Yep.
Inequality.
Yeah, these are your 4 inequality symbols.
Can I please have everyone's attention?
Okay, so any questions on those 4 inequality symbols? Yeah, and I know we're going through them kind of quick, mainly because it's review. When we go through other lessons that are new stuff, we're going to definitely slow down. And if you already know those symbols, you don't have to write them down. If you know what a less than and less than or equal to looks like, I wouldn't worry about writing it if you know it. Right, so when we graph on a number line, 2 kinds of circles. There's an open circle and a closed circle. How many people have done that kind of graphing before? Open circle, closed circle. Some people? All right, let's take a look at it. So when you graph an inequality like this on a number line, first thing you have to do is put a circle on the number you're graphing. There's 2 kinds of circles you can use. Open circle and a closed circle. How you figure out which one to use just depends on the inequality symbol. If the inequality symbol has an equal to, you fill in the circle. It's a closed circle. If the inequality is just a less than or a greater than, there's no equal to under it, that's where you use open circle. Okay, so we'll take a look at graphing example 2a. What kind of circle am I going to need right there? All right, so we're looking at graphing x is greater than or equal to 2. Is this going to be an open circle or a closed circle on 2? Yeah, because it's got the equal to under it. Equal to means use a closed circle. And now, the one on the left and the one on the right are exactly the same thing. Okay? I would prefer if you write it this way. Technically, what's on the right isn't wrong. But if you write it this way, with the variable on the left, number on the right, the inequality sign tells you which way to shade. Okay? You're shading everything greater than 2. Okay? So bigger than 2. If you write it the other way, then the inequality sign tells you the opposite way to shade. Okay? So try to stick with variable on the left, number on the right. Listen. Okay? Same kind of problem. That's the way I would prefer to write it. Both ways are exactly the same thing. What kind of circle am I going to need this time? Open circle. And am I going to shade to the left or to the right? Yeah, we're shading all values less than 3. Okay? Less than goes to the left. Okay, so that's just graphing an inequality on a number line. Now, there is a different symbol besides using an open circle and a closed circle. Okay, our book is going to sometimes use brackets and parentheses. It means exactly the same thing, just a different way to do it. Anytime you see brackets, brackets are the same thing as closed circle. Anytime you see parentheses, a parenthesis is the same thing as an open circle. So I'm going to do the same two problems again. I'm just going to show you a different way to do it. Okay? Greater than or equal to, use a closed circle, or you can use a bracket. I don't care which way you decide to do it. The only thing is, make sure you make the bracket face the way you're going to shade. That's the only difference. So I know I'm shading to the right, so I'm going to make my bracket face right. And that's it. Just a different way to shade, and you might see that in our book. Has anybody ever done it like that before? No? All right. So if I want to do y is less than 3, I could use an open circle. Or what's the other symbol I could use?
Parentheses.
Yep, parenthesis. And it would have to face which way? Yeah, it's going to be facing left. So parenthesis, shade left. Do it whichever way you want. Just, I think the book is going to use brackets and parentheses most of the time. So this inequality right here, it's got two inequality symbols in it. Okay, this is a conjunction, or sometimes we just call it an and. And it's exactly the same as writing that. Okay, this conjunction means I want x greater than or equal to 2. Okay, so you can kind of look at that part. And I want x less than or equal to 9. Right, so what's in the green box and what's in the blue box, I just separated it out down below. Whenever we have a conjunction, I'd prefer if you can write it this way. It's a little shorter. All is one statement. Important thing with a conjunction, put the variable in the middle. Make sure the inequality signs point the same way. Another way you could write this conjunction would be to switch everything around. Put the bigger number on the left, smaller number on the right, and flip the inequalities. Those two are exactly the same thing. And I don't really have a preference which way you do it. I tend to do it like the bottom though. Smaller number on the left, bigger number on the right. So if I were to graph this one, where am I going to end up shading? I'm not going to have an arrow pointing forever in one direction. I'm only going to be shading So up to 9 at the highest, and what about the lowest? 2. So this is a between. I'm going to shade between two numbers. So I'd have to put, what kind of symbol on 2? Either closed circle or bracket. Either way. What kind of symbol on 9? Closed circle or bracket. And we shade between. Okay, so that's a conjunction. Okay, absolute value. Okay, very simple idea. It's the distance from 0 on a number line. Since it's a distance, distances are always what kind of number? Always positive. So what's the absolute value of 6? Yeah, if it's already positive, it doesn't change. What about the absolute value of negative 3? 3. If it's negative, you basically take the opposite of it, and then it becomes positive. That's it. Okay, and one thing absolute value can help us do is to find the distance between 2 points on a number line. And that's the formula to find the distance between 2 points. Okay, so if I said to you this morning the temperature was 60, this afternoon it's going to be 80, and I said, what's the difference in temperature? All you have to do is subtract those two numbers and take the absolute value, and that's the difference in the temperature. Doesn't matter the order you subtracted in. You could do 60 minus 80 or 80 minus 60. If you take the absolute value, it's going to make it positive. All right, so to find the absolute value between negative 2 and negative 9, subtract them. Just be careful with your signs. Negative 2 minus negative 9. When I do negative 2 minus minus 9, what's going to happen there? Yep, it's going to become plus 9. And what's negative 2 plus 9?
7.
Which is 7. So the distance between negative 2 and negative 9 on the number line, 7 units. Okay, questions on that? Okay, next step up from doing one-dimensional graphing, we can get into two-dimensional. Okay, so when we graph in 2 dimensions, we have an x and a y-axis. And that x and y-axis separates the coordinate plane into 4 regions. Does anybody know the name we call those 4 different spots? And I've numbered them in Roman numerals. Yep, those are your 4 quadrants. On the x-axis, which direction is positive? Left or right? Yep, right is positive, left is negative. What about on the y-axis? Which direction is positive? Up, negative, down. And that's how I've represented it by writing what's the sign of the numbers in each quadrant. Where the x and the y-axis cross, that's your origin. And this is how we specify a location on the coordinate plane. What do you call this? This thing with parentheses around it.
Coordinate.
Yep, it's a coordinate. Or does anybody know the other name?
A something pair, right?
Yep, something pair.
Linear.
Ordered. Yep, ordered pair. In a coordinate or an ordered pair, x always comes first, y always comes second. Okay, I'm not going to go through graphing. I'm going to assume everyone can graph basic points if I gave them to you. All right, so zooming on a graphing calculator. So yesterday we talked a little bit about this. Zooming you might have to do if you have a graph that's off the screen. And I'll show you how to do it. Okay, once you turn your calculator on, just make sure you're at the home screen. And does anybody remember what button you have to press to see your X min, your X max, your Y min, and your Y max. Yep, you press window. And all they're asking you to do here is to change these values. That's your X min. Let's see. That's your, so we're going to go negative 20 to 20 on the x-axis. And we're going to go negative 20 to 20 on the y-axis. Okay, so that's how you write down your viewing window. And you just change it. Negative 20 to 20. And negative 20 to 20. That's it. That's all you have to do to change your window. I don't have anything typed into graph, so when I hit graph, that's all you're going to see. So what's the distance across the x-axis? How many units am I seeing on the screen? 40 on the x, and how about on the y? 40. Okay. Any questions on how to change the window? Yes? To change the window?
So I hit window.
Yeah, you hit window, and then you're just going to change x min, x max, y min, and y max.
Okay.
We don't have anything graphed, so you're not going to, nothing interesting is really going to happen here. But that's it. If we had something graphed, you'd be able to see it. Okay, so last thing. Okay, distance formula. So we already have a distance formula for a number line. Just subtract the two numbers because they're horizontal. Well, in 2D, we could have points on a diagonal. Not quite as easy to find the distance between those two. But we have a formula that allows us to do it. So if I had 2 points, just call them P and Q. And if P has coordinates x1, y1, Q has coordinates x2, y2. There's your distance formula. It's the square root of the difference in the x's squared plus the difference in the y squared. Does anybody know what formula that really is? It's another much more common formula from geometry having to do with triangles. Luke? Yeah, that's just the Pythagorean theorem. x1 minus x2, that's the length of the bottom side. y1 minus y2, that's the height of the triangle. The Pythagorean theorem says if you take each of those lengths, square them, add them up, and then take the square root, you'll get the length of the third side, which, what do we call the third side, the long side in the triangle? Yeah, that's the hypotenuse. So the distance from P to Q is really just the hypotenuse of a right triangle. Okay? That's all that formula really is. It's the Pythagorean theorem. Okay, so to find the distance between those 2 points, just fill into my formula. x1 is 1. x2 is 5. y1 is 4. And y2 is 6. And I'll leave doing the arithmetic out for you guys. But that's all you do. Okay, and the last formula for today is the midpoint formula. Okay, midpoint formula is a little different than distance. Okay, midpoint formula gives you a location, not a length. Okay, distance formula tells you a number. How long is something? Midpoint formula tells you where something is. It's a location. Does anybody remember what it's really called when you add up two numbers and divide by 2?
Average.
Yeah, it's really just an average. Okay, that's all the midpoint formula is. Add your x's up, divide by 2, gives you the average x value. Add your y's up and divide by 2, gives you the average y value. Just tells you what's right in the middle. That's all. All right, so if I added my two x's, what's -5 plus 3? It's going to give me -2. And we're going to divide by 2. And now let me add my y's. 2 plus 7. What's 2 plus 7? 9. Don't forget to divide by 2. -2 divided by 2.
-1.
Good, -1. And 9 over 2, you can leave it as a fraction. Or if they wanted a decimal, it would be
4.5.
4.5. Either way. Okay, so I know we did go through that kind of quick, but it's most, absolute value, inequality signs. Most of that you guys probably already knew. Any question on distance or midpoint formula? All right, so you guys have the rest of the time until we get called down. I'm thinking the sophomores just got let out, so probably within 5-10 minutes they'll call us down. Okay, but that's the homework for tonight on page 11. So 5 through 16, 20 to 23, 28, 31, 32, and 44. Okay, I'll take a look at that first thing tomorrow. If you didn't bring back your sheet signed, make sure you bring that back tomorrow too, because I'm going to count that as a homework. Okay, so make sure you bring that back.